Here's a nice and interesting problem regarding arithmetic number theory. Here is the following setup. Find all x, z as a natural number. Satisfy this following equation. We get x squared, which is a perfect square, equals z is multiplied by z squared plus 64. In fact, this problem, it can be written on many different ways. So basically, if you change this number into different numbers, it will have a different path of solving this problem. So let's take this for example. If you have the odd here is a square, you will have a different thing because we will have a difference in GCD. If you had just a single integer here without perfect square, which means this one is going to be simply changed into the Pell's equation. Okay, we are going to do the separate value for that. Okay, now let's take a look at this one to see what's given us. Notice here, this one is going to be this one. I'm going to take these two different cases. We are going to assume when we have z is a odd, also z is a even. Okay, now let's take these two cases. Case number one, if z is a odd, let's set equals z squared plus 64 all over z. Okay, so let's simplify this one more. Z squared over z is going to give us z plus 64, which is 2 to the 6 over z. Okay, so z is a odd. This one is arithmetically is a natural number, so but this one is not a natural number. Okay, so because this one is a power of 2, this one is a odd, which means this implies a GCD of these two terms, which is z and z squared plus 64 is going to be number 1. Okay, since we have this product, GCD of this product equals 1, which means every single term here of this product must be a perfect square. Okay, this is very known formula. So this one immediately is telling us z equals m squared, and this one z squared plus 64 is going to be n squared. Okay, we are simply going to solve this equation without using this equation. Okay, let's leave this 64 at here, move over this term to the right and factor out that on the form of the product, because we will have a difference of two squares. So this one is going to give us 64, which is 2 to the 6, which equals n minus z factor n plus z. It's more simple. Okay, so I'm going to take two different cases here. So the first equation system, I get 2 equals n minus z, because this term is smaller than the other term. The other one is going to take 2 to the 5th, which equals n plus z. The second equation system, I will have 2 to the 2, which is 4, which equals n minus z. The other one is going to take the rest, 2 to the 4th, which equals n plus z. The only two cases that we have, because you cannot choose any other case, because otherwise you will have equality. Okay, so simply solving this equation, adding this one on this one, I get 2 times n is going to give us 2 plus 2 to the 5th, which is 34. Dividing both sides by number 2, I get n equals 17. Replacing n in this one to find z. Okay, so we are simply going to give us z equals 17 minus 2, which is 15. So we get z equals 15. So I'm going to replace it here. But we get m squared is a perfect square, but 15 is not a perfect square. It's impossible. Impossible. Let's move on to this one. Adding this one on this one, I will have the same thing here. Twice n is going to give us this one plus this one, which is 16 plus 4, which is 20. Immediately is going to give us n equals 10. Doing the same thing that I have previously done, so which means doing the same thing as I did before in the previous equation. So replacing n with 10, we are simply going to get z equals n minus 4. I get 10 minus 4, which equals 6. Okay, remember z, it was odd. Now we found z is an even, and also is not a perfect square. Also it's impossible. okay? Which means oddness doesn't work in this case. Let's move on to check the evenness of this one, okay? Now let's get rid of this one and move on to the second case. This case is going to be a little more challenged because the GCD is going to give us a problem here, okay, since we have the even here. Because the GCD of this product, it could be number 2, it could be number 4, 8, 2 to the 4, 2 to the 5, 2 to the 6, and number 1. So we cannot do all the cases and check each case separately, okay? Also, it's not going to give us a nice job. We are going to change a different path of solving. It's going to be good, okay? So what to do here? If I'm going to prove this product is free of odd term or prime, it will be the same thing because the divisibility is going to be, because we are going to focus on divisibility, okay? So also I'm going to show z is free of odd integer, okay? Now let's go ahead process through this one. So let p to be odd prime or odd factor is going to be the same thing here, because if you have odd here, this odd is going to be factorized on the form of the factorization prime, as p1 to the alpha 1 is multiplied by p2 alpha 2 all the way down to the p alpha I to the alpha I, like this, okay? We don't even interest in this one because as long as we have odd or p as a prime, so we are going to interested about whatever the odd we have here, b must be super equal to 3, which means is an odd or prime, you will have the same thing because we are going to show this quantity is going to be free of any odd or prime, okay? Now let's go through this one. Let's set z equals twice is multiplied by p, okay? So this one, let's do it by the way of contradiction. By the way of contradiction, suppose, so I'm going to assume this one is true and we build our proof based on this information that we have here, okay? To do, I'm going to work on each term of this product separately, starting with this one. I'm going to replace this value here of z into this one. So we'll have x squared, which equals 2p factor 4p squared plus 64. Taking this for out of these things, I get simply 8p factor p squared plus 16, which means 4 divides x squared, okay? So let's set x equals 2 times x1 because 4 divides x, okay? So which means I get here 4 x1 squared, which equals 8p factor p squared plus 16. So what to do, I'm going to divide both sides by number 4. This one immediately is going to give us x squared x1 squared equals 2 times p factor p squared plus 16. So we get the right answer of this equation here, even, which means the left hand side of this equation must be even as well, which means this one, x1 is an even. Let's set also x1 equals 2 times x2. Let's replace this one into here. So I get here 4 x2 squared, which equals 2p factor p squared plus 16, okay? So notice here always x2 is strictly inferior than x1, okay? And also x1 is strictly inferior than x. This one is not going to help us, but we'll notice it, okay? Now let's divide both sides by number 2. So I get 2x2 squared equals p factor p squared plus 16. We get this term is an even, but this one is an odd because we know this product is an odd, which means p is an odd. This one also is an odd because p squared is an odd, adding 16 is still odd, okay? So which is clearly it's impossible. As I said before, p as a prime or odd integer is going to play the same role in this divisibility, okay? Well, we have contradicted, so we have contradicted our assumption. which means z as an even doesn't have any odd or prime factor here, which means this z is going to be changed into power 2, where is n is super equal to 1. Okay, so now we know z is a power of 2. We need to prove this one is a power of 2 as well. Now let's get rid of this one and move on to this one. I'm going to do almost the same thing but on this one now. So let's let q as a different prime, or always q is super equal to 3. So I will have this term, which is z squared plus 64, which equals 2 times is multiplied by q. Okay, because we know z is an even, which means this one is an even as well. But even though you see here 64 is the same as 2 to the 6, and also this one is an even, okay, as a power of 2, because we have z squared is going to be replaced. We know already z equals 2 to the n. Replacing this one into this one, I get 2 to the n. If we have 2 to the 2 plus 2 to the 3, this one is going to give us 12. 12 is the same as 2 to the 2 is multiplied by 3. Here is 2 consecutive power of 2 is going to give us 12. This 12 has an odd factor or odd prime. Okay, this one it will have the same thing. We are going to prove this one is free of odd prime or odd factor, whatever it is. Okay, now we are going to work on this one here. Get x squared here is going to be replaced with z 2 to the n. This one is going to replace it with 2q. This one is going to give us 2 to the n plus 1 is multiplied by q. We are not going to work on this one because it seems unclear equation here. We are going to simply work on this one exactly. Okay, what to do here? I'm simply replacing z with 2 to the n, which we have here. Okay, then dividing both sides by number 2. So it's going to give us 2 to the n minus 1 plus 2 to the 5, because I'm dividing this one by 2, is going to give us q. Remember, we are doing this one by the way of contradiction as well. Okay, this is clearly it's a contradiction because we have got odd here, but this one is even. Okay, which means this one and this one are free of odd factor or odd prime. Okay, which means this product is not involving any odd prime or odd factor. Okay, now let's work on this one since we proved that. So we get x squared equals z is going to be replaced with 2 to the n factor. 2 to the n going to be replaced with 2 to n because you have square here, plus 2 to the 6. What to do? I'm going to take these 2 to the 6 out of these things here. So I will have 2 to the n minus 6 factor to the 2n minus 6 plus number 1. Since we have proven this product has no odd factor or odd prime, which means this one is a power of 2, this one must be a power of 2 as well. Okay, this one is a power of 2, but this one is an odd. Here is a problem. We need this exponent must be 0. Okay, this exponent is going to be 0 since this one is free of odd factor. So this one immediately is going to give us 2n minus 6 equals 0. Solving this equation, I get 2n equals 6. Thus n equals 3. Now we found the value of n equals 3. Let's replace it here. Okay, so we get n equals 6 equals 3, which equals 8. Now we found the solution of z. We need to find the solution of x. It's more simple here. We get x squared, which equals z is going to be replaced with 8. This one is going to be replaced with 64 plus 64, which equals 2 to the 3. We know 64 plus 64 is 128. 2 to the 3. We know 128 is the same as 2 to the 7, which equals 2 to the 10. Taking the square root of this one, so immediately it's going to give us x equals 2 to the 5. So we found this solution. Finally, we found x equals 32 and z equals 8. This is the only solution which satisfies this equation. Okay, so I have done this problem. Thank you for watching. I will see you next video. Bye.